Alright, so in this video we are going to solve another question which is related to the differentiation using the first principle method. According to the steps which I have shown you on the right side of your screen, you can see that the first step is that we have to let the function equal to y. Now we have to add an increment in our dependent as well as the independent variable, and now we have to move this y right side of the setup. We are just gonna put y for the time being, and from here we would put the value of y into this term, right? So minus 1 over root x, right? Now what we are going to do, we are going to take an LCM of these two terms, and after that we are going to combine it. So by taking the LCM, actually we are going to combine these two terms. So the first one is root x and the second one is root x plus delta x. So these two are being multiplied, and now you know the rule for taking the LCM, that this term is being cancelled. So this would actually become root x minus this would become, as you know, this term is present over here, so this term is going to be multiplied with the number which is present in the numerator, and that would be our result. All right, and now you can see that this did not give us any fruitful result. So what should we do now? We should in the previous video, in the last section of the previous video, I told you that in such a situation where you have a negative sign, you can move towards rationalization. So we can do some rationalizations over here, and that's the only way you can proceed with this question. Okay, so this is known as rationalization, in which you take the numerator and you multiply and divide by the opposite of that equation. All right, so the opposite of that would be positive 1. Okay, now we are going to combine it. Minus x plus root x, as you know that this being multiplied, so this would be in the numerator, and the term which is in the denominator would be multiplied by the first term which is in the denominator. Okay, delta x, you can see that this is a whole term. You can see that this is a term under one denominator and this is a term under the another denominator. Okay, and now you can see that this goes the same phenomena over here which we applied in the previous video, and I'm going to explain it over here. So you can see that this can be a, this can be b, this can be a, and this can be b, right? And you can see that there's a negative sign and a positive sign. So if this term can be written as a minus b and a plus b, and there's also a multiply sign, so this whole compiles up to form a formula a square minus b square, right? So we can simply write it in this form: a square. What is a? A is actually root x, so that's the square, minus b square. What is b? X plus delta x and the whole root. So what would happen is that we are going to cancel the squares by the squares, and we get x minus x plus delta x. And remember, whenever there is a negative sign, you have to use the bracket so that it does not messes up with the thing which is present inside the bracket. Now we are going to multiply it, x minus delta x, and this is cancelled, so we get minus delta x. So we got our result in the top, that is minus root delta x actually, and this can be written as x brackets x plus x. Okay, and this is another term, root x plus, and if you're confused about what happened over here, you can see that this is a root and this is a root, and these two are being multiplied, so these can be combined under one root. Okay, I cannot combine these two terms because there is a positive sign. Whenever there is a multiply sign, you can combine them together under one root, but whenever there's a negative sign or a positive sign, it means that they are being added or they are being subtracted. You cannot compile them under one root. Okay, so this is the thing, and you can see that there is a negative delta x in the top in the numerator. So if I bring my delta x, which is according to the rules of the first principle method, I can divide delta x and it can be cancelled. I told you in my first lecture that you have to simplify it until you reach a point where you can remove delta x from the equation, from the numerator specifically. All right, so we get negative 1 in the top, and in the bottom it remains the same, that is root x plus delta x, and this root is all over the place. Okay, and this thing goes the same, x plus delta x. And now for the final step, you have to apply the limit. Okay, So I've applied the limit over here, and I'm also going to apply the limit on the right hand side of the setup. Some of the students ask me that why do we apply the limit? It actually shows that delta x, this is the most possible value of delta x, okay? This is according to the rules of the first principle method, that you have to apply delta x, limit of delta x approaches to 0. And this actually implies that delta x can only reach a point where its value can reach only 0, all right? So we can write dy by dx, and this is -1. You know, wherever there's a delta x inside the equation, you can actually put 0 over there. So this becomes 0 and this becomes 0. So what are we going to get over here? Let's see. This is the first root, x and then x. Okay, so this is the first setup. Then the second setup actually says that there is a root x by default, and this becomes 0. So we get a root x, another root x actually. Okay, so -1, and this becomes, this is being multiplied, so we get x square root, and this becomes, as you know, there is a 1 by default. If there is no number on the left side of any root, so it is 1 by default. Okay, so these ones can be added, it can become 2 delta root x, because the bases are same for the roots. Okay, and this roots can be cancelled by the squares of the x square, so this becomes x 2 root x. Okay, so this is the derivative of the function 1 divided by root x. Okay, I simply place the value of y which was given in the statement of this question, right? So I hope that this question makes sense.